All right. So let us go back now to the same concept that yesterday we were dealing with. We were talking about the power set of a set, and there we have stated that power set contains 2 raised to n elements. Power set of A contains 2 raised to n elements. 2 raised to n elements. If A has n elements. So I think this is not new to you. You have already learned this in first year of your junior college. Means in 11th standard, you have learned all those things. Now, do you know the definition of relation? Do you know what is meant by relation? Yes, what is a relation from set A to set B? Yes, what is the definition of relation from set A to set B? Can you tell me? Come on. No one? Pooja, have you learned relation? Pallavi? You can unmute yourself and answer me. Aditya? आदित्य ओमकारचा भाऊ ना? Are you all there in the classroom? Okay, we cannot waste more time here. So, relation from set A to set B, let us define a relation from set A to set B is a subset, of A cross B. A relation from set A to set B is a subset of A cross B. So let us have a Venn diagram so that you will come to know with the example. So this is my set A, and one more set let me have. This is my set B. Set A and set B I have shown. Let me denote them. So hope you are watching. And I have a function f. I have denoted the function as here. So instead I would like to go back. Okay, I'll just first name the elements of set A. So I have got small a, then here I have B, then I have one more element C, and one more, let us have D. And to this, in this set, let us include 1, 2, let me write 3, let me write 4, and let me join this kind of relation. So A I'm taking to 1. I hope you are following. Then what I do is I join B to 4. Then I join D to 1 and C, sorry, it's okay, and C to 2. So is this a relation? How I write this? So let us go to uh, set notation. All of you are following me? So what I'll do is I'll write the relation as capital R. The notation I follow is capital R and is equal to, in curly bracket, let us go on writing the ordered pairs. So what are the ordered pairs with us? First I write ordered pair A comma, yeah, A is joined to 1. So A comma 1 comma, then I go to ordered pair B comma 4 as you're watching. Am I right? Then I go to ordered pair C comma 2. Sure. So both ways I'm showing diagrammatically also, and I'm writing in set notation also. So round bracket D comma 1 and the bracket close. So this is nothing but one relation I have written, and what I'll do is I'll denote this relation as R1. First relation R1. Okay, so this is a relation because every first entry is from set A, every second entry as you are watching is from set B. So this is subset of A cross B. So let us continue with the same. Just a minute. So we are continuing with the same, and you can write it as a subset of, because I don't have proper notations here. So I write subset of, and let me write A cross B. You have set notation with you, so you can write in your language. All of you know very well how to write it. Subset of A, elongated C you write. So if I draw it, you write the elongated C. This notation I'm not having, so I wrote it as subset of. Clear? Okay. Now let us go for another relation. So let me write it in terms of R2. So let us write it as R2, and I can just add few more things here. Few more things. So because I have additionally added, so let me change the color. Let me join A to 2. Let me join B to 3. A to 2 I have joined. So now coming out, let me join B to 3. Then let me join C to 4. Let me join D to 3 back. Let me join A to 4 also. So how do I write these kind of relations? Let us go back here. And what you observe here is R2 you can write as equal to curly bracket. So whatever you have now presently on the board, that I'm just noting. So round bracket A comma 1 is seen over there, comma A is joined to 2 also. So write ordered pair A2. Then I go for A is joined to 4 also. Yeah, so I write it as A comma 4. Then I go to B. So all of you are watching, B is joined to 3 and B is joined to 4 also. So B is joined to 3 and B is joined to 4. This is all about B, and then I go for next is comma C join to 2. Then C join to 4 also. So I have C comma 4. I hope it is visible. And the last element I'm left with is D. So let us write D with 1. Yeah, it is that. And what I have is one more. D is joined to 3. Are you getting the thing? What you observe is R2 is also a subset of A cross B, because every ordered pair has first place element from set A and second place element from set B. So who is playing with the board? Keval, is it you? Okay. So I hope all of you are observing. This is the relation that we talk of. Clear? So I hope there is no problem as far as relation is concerned. So you can read the relation from here, and you got the definition. Relation is nothing but the set of ordered pairs from set A to set B. But you know, A cross B gives you set of all ordered pairs. So in simple words, you can call it as a subset of A cross B. I hope you're getting it. Is relation is nothing but a subset of A cross B. So I hope you have taken down, you have copied it down. Definition of relation is a relation from set A to set B is a subset of A cross B. And you might have taken down these two relations. Hope no doubt at all. This is actually over in 11th standard. Now if it is over, I would like to share a next slide. So a relation can be, and all of you are observing, it may be 1 1, it may be many 1. So there is no such restriction. Even it can be 1 many. As you have observed, 1 was attached to so many things. So 1 many is allowed, and even many is also allowed. I hope there is no problem. So a relation can be 1 1 relation, it may be many 1, it may be 1 many, and even it may be many. So hope there is no problem at all. Have you got me? I want response from you. Nobody's answering. Come on. Is there any problem? So only 7 people. 7 means including myself. Only 5 were there. Pooja, are you getting me?
Yes, ma'am.
Okay. So hope the thing was not new to you. The thing was very clear. Okay. Rekha, unmute yourself and answer me. Unmute yourself. Are you there in the class? Avishkar, are you getting the point? Okay. So let us go ahead. I think the concept is so plain, so easy. So I need not waste my time here. All right. Now, when I say a relation on set A, relation, relation on a set, relation on a set means what? The set is the same. A relation, please take it down. A relation on a set capital a relation on a set capital A is a subset is a subset of A cross A. A relation on set A is a subset of A cross A. I feel you are getting me. Okay, means what? Both domain and codomain are same. In that case, we call it as a relation on a set. Now, a relation on a set can have three properties that you have already learned in your 11th, 12th. What are they? So, a relation can be reflexive relation. Reflexive relation. Can anybody answer what is a reflexive relation? Yes. Can you tell me what is a reflexive relation? Yes, come on. What is a reflexive relation? Anybody? So it's natural thing that I'm talking about a relation on a set. I'm taking the same set again. So while describing reflexive relation, just see, I'll draw A and again let me draw A back. Suppose the elements in A are 1, 2 and 3. And here also I'm having same set, so it will be 1. Same set I'm copying 2 and 3. Now let us am I audible?
इको वॉइस मॅम ऑडिओ नाही येते तुमचा.
हा, आवाज नाही येत आहे?
हा, आता येतोय.
ओके, सो आपण तोच सेट काढला, सेट ए घेतला आणि स्वतःशी क्रॉस प्रोडक्ट आपण विचार करतोय. सो हिअर ऑल्सो आय हॅव रिटन सेट ए and we are talking about the relation from set A to set A itself. Set A to set A itself. So if I join 1 to 1, then I join 1 to 2, then I join 2 to 1, I join 2 to 3, then I have joined 3 to 3 itself. Is this relation reflexive? Is this relation reflexive? What do you think? Is it reflexive? So the concept is already over. I want to know whether you have understood reflexivity in 11th or not. Come on. I want to check whether it is reflexive. Yes, can you? Is it reflexive? कोणीच नाही सांगत आहे, काय भानगड आहे? रिफ्लेक्सिव्ह म्हणजे काय? तो इलेमेंट स्वतःशी रिलेटेड आहे किंवा नाही ते बघायचं आहे. Is every element related to itself? So is one related to itself? Is one related to itself? Come on. Yes, one is related to itself. It is shown there. Let me use spotlight. Yes, one goes to one. You're watching, one goes to one. One is related to itself. What about two? Is the two related to itself? No, there is no relation from 2 to 2. What about 3? Yes, 3 is related to itself. If every element is related to itself, we call it as reflexive. So what is your opinion? Is this relation reflexive?
No.
nahi hai, कारण 2 is not related to itself. So what is your answer? Your answer is this relation. Let us note it. Let us have to give notation. Let us call this relation as R. If you have drawn it, let us write R is not reflexive. R is not reflexive as ordered pair 2, 2. Ordered pair 2, 2 does not belong to, belongs to the sign and does not. So we are cancelling it. Does not belong to capital A. Does not belong to capital A. I hope you are watching it. Does not belong to capital A. Is it clear? So what happens? Which relation is a reflexive relation then? So definition of reflexive relation. A relation capital R on a non-empty set capital A is said to be reflexive if ordered pair x comma x belongs to belongs to the set capital R for every small x belonging to capital A. Belonging to capital A. So I hope you are watching this definition. A relation R on a non-empty set A is said to be reflexive. So let me underline the word reflexive. Is said to be reflexive if ordered per xx belongs to R for every x belonging to S. So for every it is very, very essential. Hope it is over. And already you have done this. Have you? This is over in 11th standard. Copied it down. Shall we go next? Now let us go to the next example. Let capital A equal to curly bracket 1, 2, 6, 7 and capital R equal to curly bracket ordered per 1, 1, comma ordered per 1, 6, ordered per 1, 7, ordered pair 2, 6, ordered pair 6, 6, ordered pair 7, 7, is R reflexive? Come on. Is this over? Rekha, have you done it? Yes. Is it over? Is it reflexive? How is the relation? If you want to picturize, you can. What are the elements with you? 1, then it goes to 2, then it goes to 6, and the last one they have given is 7. Here also the same thing. 1, 2, 6 and 7. Okay, and what you are observing is 1 is mapped to 1, 1 is mapped 1 is mapped to 6, even 1 is mapped to 7, then you have 2 mapped to 6, then you have okay. So all of you will go through the test. Test will be posted on the WhatsApp group. Okay. So for the time being, let us stop here itself. Thank you.